Okay, this is section 3.3 over complex numbers. All right. Now, when we talk about complex numbers, we're talking about incorporating the term I. And we'll get into what a complex number is in just a minute. So first, we need to understand these are given statements that uh, are just that. They've been given to us. So I is equal to the square root of -1. And then I squared is equal to -1. So you can see how we get the I squared is equal to -1. If you square both sides, I squared would be I squared. And then when you square this radical, the square and the square root knock each other out to just leave you with the -1. Okay. If B is a positive real number, then the square root of -b is going to be I times the square root of b. So basically, anytime you have a negative inside of a radical, that's just going to pull out as an I, but I'm going to show you why this works. So number one, the square root of -100. Now, I can't answer that. If this were the square root of 100, I would know that's just 10. But I need a number times itself to give me -100. So if you think, oh, well, 10 and -10 gives you -100, but 10 and -10 are two different numbers, they're not the same number. Okay. So the only way I can do this is I'm going to end up having an I in my answer. So I'm going to split this into -1 times 100, the square root of -1 times 100. Now, what did we say that -1 was equal to? -1 is equal to I squared. And then here's my, okay. Now 100 is a perfect square. So that comes out as 10. And the square root of I squared is just I. So again, compare the square root of -100 to your answer. So you can see how the square root of 100 is 10. And the I had to come from, well, what's the only thing that's left inside? The negative. Okay, so anytime you have a negative inside of a radical, it's going to turn out to pop outside to be an I. Now that I've told you that, I don't expect you to do this. Just go straight to your answer. So I have a negative inside the radical. So that's an I. That's what's going to come outside. Now 36 is a perfect square, which is 6. So my answer for this is just 6I. And that's it. Okay, for number 3, I cannot take the square root of 6. It's not a perfect square. And if I break it apart to look for a perfect square, well, that would be 2 times 3. And neither of those are perfect squares. So the only thing I can do is take an I out. So this would be I root 6. Okay. Now, number 4, let me do this off to the side. I showed this in one of the review videos. I think it was 3-1. Yep, it was in 3-1. So I'm just going to list my perfect square. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and then I'm just going to put dot, dot, dot. Okay. You get the idea. Okay. Now I saw this and this made so much more sense. Although I do this in my head anyways, but to explain it, I think this made a lot more sense. Okay. So first of all, the first thing that I'm going to do is take this negative that's inside. I'm going to bring it out front. So this is going to give me I root 50. Okay. Now I'm going to take 50. 50 is going to land here, somewhere in between these two perfect squares. Okay. So I don't want to divide by 64, then 81, 100 going down because that's not going to clean up my answer. That's going to give me a fraction. So I want to divide by going up. So 50 divided by 49, no, it's not a nice number. 50 divided by 36, no. 50 divided by 25, yes, that's 25 and 2. So that means I found my largest perfect square. So this just cleans up to, let me do it this way. This cleans up to 25 times 2. And I'm going to split it up this way so that hopefully this is going to make more sense. So I'm going to put in green, I'm going to put the 25 because that's my perfect square. And then here's the non-perfect square, the 2. So the square root, whoops, I'm sorry, guys. I don't know how long this has been here. That should not, sorry about that. Let's see. This goes here. Sorry. And there. Okay. So now my answer, well, the square root of 25 is 5. Here's the I. And then the square root of 2 goes at the end. Okay. That's how that works. Okay. Now let's look at the next one. Okay, so we have the square root of negative 48. So again, the first thing that I'm going to do is pull that negative out as an I. All right, so 48 is going to fall in between 36 and 49. So I'm going to start dividing by 36. No, that's not nice. 48 is not divisible by 25. 48 divided by 16. Yes, that's 16 times 3. So here's the I. My perfect square is going to be the 16. And then here's the 3. That would give me 16 times 3 is 48. So now I clean up my answer. The square root of 16 is 4. There's the I. And then the root 3 is left over. Okay. All right. Now for number 6, there's the minus that's outside. This minus sign that's inside of the radical is going to be an I. And then 16 is a perfect square, which is 4. So this just turns out to be negative 4i. Okay. All right. Now, when we look at these next examples, the only way that I can combine my radicals is if they are positive. I cannot combine these because these are going to give me, those are going to be imaginary numbers. Okay, so what I'm going to do first is for each one, I'm going to go ahead and take the negative sign. So inside, this is going to give me, this will give me a 2i. This one is going to give me a 5i. Both of them are perfect squares and they both have negatives. Okay, so the negatives came outside as an I, and then the square root of 4 is 2, the square root of 25 is 5. Now I multiply. So 2 times 5 is 10. I times I is I squared. But remember, I squared is negative 1. So I'm going to replace the I squared with a negative 1. And this is going to turn my answer into negative 10. Okay. All right, number 18. So I'm going to go ahead, take the I out, and that leaves me with the square root of 10. And then for the square root of negative 40, I'm going to take the I out, and that leaves me with 40. Now, why didn't I break apart the 40? The 10, I know there's not a perfect square, but the 40, there is. Okay, here's why. So I times I is I squared, and then the square root of 10 times the square root of 40 is the square root of 400. Okay. Now, I squared is the same thing as -1, which just means this is going to turn into a negative answer. This is just going to be a negative. Okay. Now, the square root of 400. Well, I made my little chart off to the side, but I only ended up going to 144. I don't want to have to go all the way to 400. Well, we don't have to because 400 is a perfect square. This would be, I could break this up as the square root of 4 times the square root of 100. And doesn't that still give me the square root of 400? Okay, so here's the negative sign that's outside. The square root of 4 is 2, and the square root of 100 is 10. So this just gives me -20. Okay, that was it. All right, now 9 is a little tricky. I cannot divide this because this has a negative and that doesn't, which is okay, but that negative is in the way. So what I'm going to do is take the negative out, and that gives me I root 98 over root 2. Now I'm going to go ahead and combine this. So this would be I times the square root of 98 over 2. And what is 98 over 2? Well, that's just 49, which is a perfect square, and that's 7. And then the I just goes at the end. Okay, so that one wasn't too bad. Okay, all right, now we get into what a complex number is. So a complex number is written in the form a plus bi. And your answer, if you have a complex number, it must be written in this form. All right, Alex will mark it wrong if it's not in this form. So given real numbers a and b, a number written in standard form, a plus bi, is called a complex number. A is the real part. B is the imaginary part because that's what is stuck with the I. Okay, so if B is 0, then the complex number a plus bi, if B is 0, then all you're going to be left with is A. So that would just be a real number. So in other words, 4 plus 0i is just 4 because 0 times I is 0, right? If A is 0 and B is not, then if A is 0, then we have the pure imaginary number. 0 plus 6i, well, that's just 6i. So I can make any number a complex number by putting, if I have the number, a real number, I can just put in a 0i and I have made it an imaginary number. Okay, so what they want you to do here is simplify and write the result in standard form a plus bi. So for number 10, if we have -5, to turn this into a complex number, I am missing the imaginary part. So that's just going to be plus 0i. Now I have a complex number. Okay. For 11, I have the imaginary part. I don't have the real number, so I'm just going to put a 0. And this is going to be plus 17i. So again, a plus bi, a plus bi. Okay. Now, number 5, we need to simplify this. We need to simplify the square root of -12. Okay, well, the negative is going to come outside as an I. And then 12, we can break that apart as 4 times 3, right? So let me go ahead and do that. So that's going to be the square root of 4 times 3. So we have 5 minus, well, that's going to be 2i times the square root of 3. Okay? So be careful how you do that. Now, I would not suggest that you write the I at the end because sometimes it looks like the I might be inside of a radical, and that is never the case. The I is never inside of the radical. All right. So you got to be careful about that. All right. Now, number 13, I notice these two terms can be reduced because remember, a plus b over c, going back to fractions, this is the same thing as a over c plus b over c. They share a denominator. So this could be written as 6/3 plus 5/3 I. And then I put the I in the middle. Don't put it in the bottom. For sure, don't put it in the bottom. And this just simplifies to 2 plus 5/3 I. And that's it. Okay. Number 14, 2 plus, here's the I. Now 8, we can break apart. Okay, well, I went to grab the other green one, and this one doesn't seem to be working. Okay, so this is going to be the square root of 4 times the square root of 2, all over 10. Okay, so minus 2 plus the square root of 4 is 2. There's your I. Here's the square root of 2. And then we're going to divide by 10. Now, there's a trick here because I can reduce this. So what I want to look for is if I notice that these three numbers can be reduced, then we're going to divide by what they can be reduced by. So they can be divided by 2. So that means my answer is going to be -1 plus I root 2 all over 5. Okay, and that's my answer. That's the simplified answer. Okay, now the powers of I. Okay, so let me just write this off to the side. So the powers of I, you have 4 basic powers. So we say that I is equal to I is -1, I to the third, oops, I'm sorry, I squared is -1. I to the third is -I because that would be I times I squared. So I times -1 is -I. And then I to the fourth is I squared times I squared. So -1 times -1 is just 1. Now, anything after that, it just cycles back through. So 1, 2, 3, 4, I to the fifth, I to the sixth, I to the seventh, I to the eighth, I to the ninth, 10th, 11th, 12th, 13, 14, 15, 16, 17, 18, 19, 20, and so on and so on and so on. So we can find these powers really, really quick. Okay. So I squared, that's -1. I to the third is going to be -I. I to the fourth is 1. And then I to the fifth, this is where we loop back around. So I to the fifth is the same thing as I. Okay. Now, when you have higher powers of I, well, it depends on how big the number is. So this is I to the ninth. Well, this isn't too bad for me just to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I to the ninth is the same thing as I. Okay. So we're good with that one. Now, I to the 16th, well, you could do the same thing and loop back around if you wanted to. Okay, so the closest multiple I can get to 34 of 4, so 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, 4 times 8 is 32. And this is I to the 34th power. So this is I to the 32nd power. So that's 8 cycles through. So 32, 33, 34. So this is going to be the same thing as I squared, which is -1. Okay. And then we won't worry about the -1. Okay. Now you have questions in your homework about the powers of I, but I'm not going to ask you. I'm not going to ask you a question like this on the test. Okay. Now, how do we perform operations with complex numbers? Just like um, any other thing we've done where we've added, subtracted, and multiplied. The only kicker is when you multiply and you end up with an I squared, remember you're going to have to replace it with -1. So for number 18, we're adding two complex numbers. So here's the good news. If you're adding or subtracting, make sure that you subtract, you distribute that negative, but then you just combine your like terms. So this is going to be 16 minus 3i minus 3 plus 5i. Now remember, a complex number is a plus bi. So we need the real number first. So 16 minus 3 is 13. And then the imaginary -3 plus 5i is a positive 2i. So this is just 13 plus 2i. Man, look how easy that is. Okay. 19, we have to distribute the negative through. 8 plus 7i, be careful, plus 2 minus 6i, and then combine like terms. 8 plus 2 is 10. 7i minus 6i is just I. So 10 minus I. That's all you do when you add or subtract. It's just like you do with polynomials. Okay? Combine your like terms. But for complex numbers, you have to make sure that it's in A plus BI form. Okay, number 20. This looks like a foiling issue. So let's foil. So -4i times 3 is -12i. -4i times -2 is a positive 8i squared. Except remember that I squared is -1. So we get -12i minus 8. This is not in complex form, so I have to flip this. -8 minus 12i. That is my correct answer. If you enter this in ALEKS, it'll say that you probably have, it'll probably say you have a form of the answer. Okay, you have to flip it, A plus BI. All right, 21. This looks like a foiling issue. So let's foil. So first, 4 times 3 is 12. Outer, 4 times 2i is plus 8i. Inner, minus 5i times 3 is minus 15i. And last is going to give us a minus 10i squared. Okay, so 12, I'm going to combine my i's. I and minus 15i is minus 7i. And now here's what I always do. I know that this I squared is a -1, and all that does is flip the sign that's in front. So that's what I do. I circle the I squared and I draw an arrow to the sign in front so that it reminds me to change my sign. So now 12 plus 10 is 22 minus 7i. Okay. Then we have 22. Okay. Now here, this means that we need to expand 6 minus 7i times 6 minus 7i. And now we're going to FOIL. First, it's a 36. Outer is a minus 42i. Inner is another minus 42i. And last is a 49i squared. Okay, now let's clean this up. 36. My two middle terms do not cancel. They're both negative. So that's negative 84i. And then I have this I squared, which changes that sign to a minus. So that's a minus 49. Okay, so now 36 minus 49 is a minus 13 minus 84i. And that's my answer. Okay. Now 23, these are conjugates. So remember, when you have conjugates, a plus b times a minus b, that just turns into a squared minus b squared. So it's just these two terms multiplied together and those two terms multiplied together. We don't have a middle term. They cancel out. So 2 times 2 is 4. Minus 5i times positive 5i is a minus 25i squared. But this I squared, remember that it's going to change the sign in front. So we get 4 plus 25, and that's going to equal 29. Okay? So it's not too bad. All right. Now, let's look at the division. We're not going to do number 28. Okay. So again, they just reiterate the thing about conjugates. Okay, which we already talked about. Now, when we divide complex numbers, we will make the denominator a real number by multiplying the numerator and the denominator by the complex conjugate of the denominator. Okay, so we're going to rationalize the denominator. The quotient can be written in the form a plus bi. Now, if you want practice or if you want a more detailed explanation, then I suggest that you go back and watch section 3.2, which is a review section, but I do explain how to rationalize the denominator. Okay. All right. So 25. So since we have binomials, I'm going to put both of those in parentheses. Now I want the conjugate. So the conjugate of a plus bi is a minus bi. And the conjugate of a minus bi is a plus bi. So we have a plus bi. So its conjugate would be 2 minus 6i. And then whatever I do to the bottom, I have to do it to the top. Okay, so now in the top, we're going to FOIL. So we get negative 2 times 2, that's negative 4. Negative 2 times negative 6i, that's a positive 12i. 7i times 2, that's a positive 14i. 7i times negative 6i is a negative 42i squared. Then in the denominator, this is just 2 times 2, which is 4. And 6i times negative 6i, which is negative 36i squared. Okay, now remember what these I squareds do. They are going to change the signs that are in front. Okay, so in the top, we're going to have negative 4. I'm going to combine my two middle terms. So that's plus 26i. This is going to turn into a positive 42 all over 4 plus 36. Okay, so minus 4 plus 42, that's 38 plus 26i all over 40. Okay, now, like I had mentioned before on this example, number 14, pay attention to those three numbers, okay? And we have the same scenario, 38, 26, and 40. Those are all even numbers, which means I can divide by 2. So I'm going to do that. So 38 divided by 2 is 19, plus 26 divided by 2 is 13. There's the I. 40 divided by 2 is 20. And here is our solution, our answer. 19 plus 13i over 20. Now, if Alex gets picky and wants it in pure a plus bi form, then you're going to have to split this apart. 19 over 20 plus 13 over 20 times I. Okay, but I think it should take that. Okay, so 26. You can pause the video here if you want. All right, so the conjugate is going to be 1 plus 3i. Oh, I meant to do this in red, sorry. Okay, so let's do that. So 1 plus 3i. Top and bottom. Okay, so in the top, we have to FOIL. So here we go. 1 times 1 is 1. Outer is a 3i. Inner is a minus 8i. Last is a minus 24i squared. The bottom, 1 times 1 is 1. Negative 3i times positive 3i is a negative 9i squared. Don't forget about these I squareds. Remember, they change the signs in front. So 1 minus 5i plus 24 over 1 plus 9. Okay, so we get 25 minus 5i over 10. And we can reduce. So this time we're going to divide by 5. All right, so that's going to give us 5 minus I over 2. And that's it. Okay. Now 27. 27 is a little tricky, but remember, I can make this a complex number by putting 0 plus 4i. So what is the conjugate of 0 plus 4i? And that would be 0 minus 4i. Now, since I don't need the 0, then the conjugate of 4i is going to be minus 4i. So I'm going to multiply the top and the bottom by minus 4i. Okay, so the top is a distribution. Negative 4i times 4 is negative 16i plus 12i squared over minus 16i squared. Okay, so we have these I squareds, which changes those signs. So minus 16i minus 12 over 16. So I'm going to go ahead and turn this around. Minus 12 minus 16i over 16. And then those three numbers we can divide by 4. So that means that our answer is going to be negative 3 minus 4i over 4. Okay, now we did reduce this. However, I haven't reduced it completely. So what I'm going to have to do is split this up. This is going to be minus 3 over 4 minus 4 over 4 times I, because I can still reduce the 4s. So this is negative 3/4 minus I. Okay, so be careful when you're cleaning up your answer. All right, that's it for section 3.3.